Welcome everyone to Locked in Review. Today we are breaking down everything you need to know for AP Calculus AB/BC, specifically focusing on Unit 1, limits and continuity. Just as a quick disclaimer, I am an AI voice model from Clipchamp, so if I make a slight pronunciation or reading error, please check the screen to find exactly what you need. Let's lock in. Let's start with the core foundational concept. What exactly is a limit? A limit describes the behavior of function f of x as x approaches a specific value. It is crucially important to understand that a limit is not always what the function equals at x equals c, but rather the value of what it approaches. Mathematically, we write this as f of x gets close to L as x approaches c, or the limit of f of x as x approaches c is L. This gives us our standard notation. The limit as x approaches c of f of x equals L. When analyzing this, you always want to look at the graph from both the left and right sides. For a general limit to exist, the one-sided limits must equal each other. Keep in mind that holes, also known as removable discontinuities, do not affect the limit's existence. However, jumps and vertical asymptotes will cause the limit to not exist, or DNE. Moving into graphical estimation, we can visually determine whether a limit or a function value exists. For instance, at a hole, the limit of f of x exists, but the actual function value f of x does not exist. On the other hand, at a vertical asymptote, the limit of f of x does not exist, and the function value f of x also does not exist. When you aren't looking at a graph, you'll need to use algebraic evaluation. Your very first step should always be direct substitution. Simply plug in x equals c. If direct substitution gives you a real number, like plugging 5 into x squared to get 25, you are done. However, if direct substitution results in 0 divided by 0, you have encountered an indeterminate form. When this happens, you have a few tools. First, you can try factoring. Factor the numerator and denominator to cancel out the trouble factor. For example, the limit as x approaches 2 of this expression can be rewritten by factoring the top into x minus 3 times x minus 2, canceling the x minus 2 factors, leaving you with the limit of x minus 3, which evaluates directly to -1. Second, you can try rationalizing. Use the conjugate for limits involving square roots to clear the radical. The conjugate is just the term with a flipped sign to create a difference of squares. In this case, root x minus 2 has the conjugate root x plus 2. Lastly, make sure to memorize the limit as x approaches 0 of sine of x divided by x, which equals 1. We'll explain why in Unit 4. Next up is a highly tested concept, the squeeze theorem. Let's look at the setup. If you have a situation where g of x less than f of x less than h of x for all x near c, and both of those outer functions approach the exact same limit, L, then we reach our conclusion. The middle function f of x must also approach L. Formally, if the limit as x approaches c of g of x equals L, and the limit as x approaches c of h of x equals L, this implies that the limit as x approaches c of f of x must equal L at the point c, L. When dealing with infinite limits, your first step is to check for a non-zero number over 0. If your direct substitution results in a constant k over 0, where k is not 0, you know you have a vertical asymptote. To determine whether the function is approaching positive infinity or negative infinity, you should test points extremely close to k, such as k minus 0.1 from the left and k plus 0.1 from the right, to find the resulting sign of the function. Now let's switch gears to horizontal asymptotes and in behavior. Horizontal asymptotes occur when x approaches infinity or negative infinity. For rational functions, you can easily find the limit by comparing the degrees of the numerator and denominator. If the function is bottom-heavy, the limit equals 0. If the degrees are an equal degree, the limit is simply the ratio of the leading coefficients. If the function is top-heavy, the limit will head toward positive or negative infinity, meaning there is no horizontal asymptote. This tracks how the limit of f of x behaves as x shoots out to the far edges of the graph. Next, let's look at defining continuity. For a function to be continuous at a point c, it must satisfy three strict conditions. First, it must be defined. F of c must exist, meaning there is no hole or gap at the point itself. Second, it must be approachable. The general limit as x approaches c of f of x must exist, which requires the left-hand limit to equal the right-hand limit. Third, there must be a match. The limit as x approaches c of f of x must explicitly equal the actual function value f of c. The limit must equal the point. If a function fails any of those three conditions, you are dealing with a discontinuity. There are three major types of discontinuities you need to recognize on the AP exam. First is a removable discontinuity, which is just a single hole in the graph. Second is a jump discontinuity, which is incredibly common in piecewise functions where the graph breaks and starts at a different height. Third is an infinite discontinuity, which is always found at vertical asymptotes where the graph shoots up or down infinitely. Finally, we have the intermediate value theorem, or IVT. To apply this theorem, you must always state its required conditions first. The function f of x must be completely continuous on the closed interval. If it is continuous, and you have a value k such that f of a less than k less than f of b, the theorem guarantees that there exists at least one value c within the open interval, a, b, such that f of c equals k. This theorem is incredibly useful on the AP exam for proving that a function has a zero or a root, specifically if you can show that f of a and f of b have completely different signs, meaning one is positive and one is negative. And that wraps up our locked-in review for AP Calculus Unit 1, Limits and Continuity. Make sure you memorize those continuity conditions and rational function rules. If this breakdown helped you feel more confident, make sure to like, subscribe, and drop any questions you have in the comments below. Stay locked in, and I'll see you in the next review.